Hello and welcome. So in this video, we're going to talk about probability of the union of events. So let's consider two events in our sample space. So the probability that E or F will occur is given by this formula. So the probability of E occurring plus the probability of event F occurring minus the probability of E and F occurring. So that's the intersection. So knowing this formula, let's go ahead and dive into our first example. Let's take a look at this example. So we have this experiment where we're working with 52 deck of cards. Now, if you're not familiar with how many cards and what type we have, I have a picture for you right here. So one card is drawn from an ordinary deck of 52 cards. We want to find the probability of each of these. So let's go ahead and start. So our sample space is consists of 52 cards. So this is the sample space S, let's call it that. So we have 4 suits. We have heart, and there are 13 of them. One is the A, and then you have numbers 2 to 10, and then you have the face cards. So the Jack, King, and Queen, they're known as the face cards. So there are 13 of each suit. So in total, you have 52 of them. So 13 hearts, 13 clubs, and then 13 diamonds, and 13 spades. So there are 13 of each in this sample space. Now, what's the probability for A? We're going to get a 5 or a 6. So we want to know what's the probability we're going to pull out 5 or a 6. So let's go ahead and see how we can use the formula we wrote down above. So you can define events. Let's say let E be the event of getting the card showing 5 and F be the event getting a 6. So the probability that we're going to get an event E or F, a 5 or a 6, it's going to be the probability of getting a 5, which is E, plus the probability of getting event F, minus the probability of getting E and F. Now let's think about this. Can you get a card that has 5 and 6 on it? Well, no, right? If you pull out a card, you can only get a 5 or a 6. Therefore, it doesn't make sense to keep the intersection there. So this is 0. There's no way you're going to pull out a 5 and a 6 if you're only pulling one card. So that becomes our formula. Now, what's the probability we're going to get a 5? Probably that the card will show 5. So that's these options, and there are 4 of them. That's going to be 4 out of the sample outcomes, so that's 52. And then the next event we said is F, which is to get a 6, the card that shows 6. So there's, again, 4 of those. So that gives us 4 out of 52. And if you add them up, you get 8 out of 52. And that will simplify to simply 2 out of 13. So that's the probability you're going to get either a 5 or a 6. Okay, so moving on to the next part. So we want to get a black card or an 8. All right, so we want to know, so again, you can define events. Let B stand for black card. And we want to get an 8. So let's say E is for getting a card that has number 8. So what's the probability we're going to get a B or E? So that would be the probability of B plus the probability of E minus the probability of the intersection. B and getting 8. All right, so let's fill this in. Now, in this problem, we are going to have an intersection. So if you look at the sample space, so which card is a black and it's number 8? So black card and number 8, well, that's this one and this one. So it looks like there's only 2 outcomes for that. So that's 2 out of 52. So the intersection happens to be 2 out of 52. And then what's the probability we're going to get a black card? Well, there's 2 suits that's black, clubs and spades. So therefore, there's 13 of these and 13 of those. We have 26 of those. So getting a black card would be 26 out of 52. And what's the probability we're going to get an 8? So there's these card listed as number 8, so there's 4 of those. So for probability of E, we have 4 out of 52. And subtract the intersection, so this will simplify to 28 out of 52, which is 7 out of 13. So that's the probability where there is an intersection, and this is the probability for getting a black card or it's an 8. Okay, so let's move on to the next event. We want to find the probability that it is the card 10 or a black 9. So what's the probability we're going to get a 10 or a black 9? So let's let T be equals to getting 10, and we said we wanted a black 9, so let's say B is for getting a black 9. So we want to know probability of getting T or B. That is the probability of T plus the probability of B minus the probability of T and B. Well, let's think about it again. Can we get a 10 and that is a black card with number 9 on it? Well, again, no, right? So this happens to be 0 in this case. There's no way we can get a card that is 10 and then it is also a black 9. So we just need to find probability of getting 10 and probability of getting a black 9. So probability of getting 10, if you look at the sample space, we have there are 4 cards that has 10, so that's 4 out of 52, plus black 9, there's how many black, and that's 9. Well, that's only this one and this one, because there's 2 suits. So we get 2 out of 52. And we know there is no intersection because there is no way you can get a 10 and a black 9. So if I combine this, I get 6 out of 52, which would simplify to 3 out of 26. So that would be the probability for this category. All right, so let's take a look at the next one. So again, pause the video, work it out on your own, and see if you can get the answer. We want to know what's the probability we get club or a red card. So let's use C for club and R for red. So probability of getting club or a red card. So let's use C for getting club and R for getting a red card. So this is going to be the probability of getting C plus the probability of R minus the probability it's a club and it's a red card. Well, again, we should realize that there's no way we can get a club and red because the red cards are red. Those are hearts and diamonds. Clubs is the black card. So this is going to be 0. So probability of getting clubs, well, we have 13 of them. That's 13 out of 52. Plus probability of getting red, well, there are 26 of them. Hearts and diamonds, that's 26 out of 52. So we know this will simplify to 1/4 plus 1/2. That will give us a 3/4. So that's the probability of getting either a club or a red card. All right, so again, pause the video and try out the next part. Part E, we want to know what's the probability we're going to get a face card or a heart. So let's do that. So probability that we're going to get a face card or a heart, let's use F for face and H for heart, is the probability of getting a face card plus the probability of getting a heart minus the probability of face and a heart. So we know their face cards are, well, the face cards are how many? Well, these are the face cards. So there's 3 of each suit. So there are 4 suits, 3 times 4, that's 12. So we have 12 face cards, 12 out of 52. Plus hearts, we know there are 13 of them. So 13 out of 52. Minus, now what about face and a heart? So we have face cards right here and a heart right here. So they intersect right here. 3 out of 52. So we have 3 out of 52 for intersection. And then if you combine this, this will give you 25 out of 52 minus 3 out of 52, which would be 22 out of 52. That simplifies to 11 out of 26. So that's the probability of getting a face card or a heart. All right, so that's it for this video. I hope you enjoyed. Take care.